Hi guys, this is Mrs. Youngman, and today we're going to be looking at triangles. So looking at different classifications of triangles. I have pictures in here for you. You can classify triangles two ways. You can either classify them by their angles. So the angles, the acute angles, if each triangle has 3 acute angles, you classify that as an acute triangle. There's a special type where you have 3 different acute angles, but if they're all congruent, you call that equal angular. And then these last two, you will just have one of this type of angle. If you have one obtuse angle, meaning one angle that's greater than 90 degrees, that's called an obtuse triangle. And if you have one angle that's exactly 90 degrees, you call that a right triangle. So some of these questions are just going to say classify it by its angles, and you would just be picking out one of those words. If it's equal angular, please use that word instead of acute, because all equal angulars are going to be a type of acute. So looking at these should be fairly straightforward. We're just classifying them as acute, equal angular, obtuse, or right. For this one here, looking at these angles, there's one obtuse angle. So that would make this an obtuse triangle. For this one, because all of those are 60 degrees, that means all of those are congruent. I would call this one equal angular. It is also acute, but again, you want to use that more specific word. So for this one here, there's more than one triangle. So here it's asking about PQR. So for PQR, for this entire triangle, I would look at this and say, okay, well, this angle here would be both of those two angles added together. So that's going to be 104 degrees. So this whole triangle would be obtuse. They might ask you for a different triangle. Like let's say, for example, they ask you about triangle QPS. If they ask you about QPS, you would just be looking at this portion. And even though there's no angle filled in here, you know that this one's 90, and those have to be supplementary, so this one here would also be 90. So that one would be considered a right triangle. And when you have more than one triangle in a picture like this, you just have to make sure that you're looking at just the triangle they're asking you for. So that's classifying them by their angles. There's other words that you can use to classify them by their sides. And these, again, should also just be kind of review words. When you have 3 sides that are all congruent, that's called equilateral. When you have 2 congruent sides, and actually it says at least 2 congruent sides, that's considered isosceles. And when none of them are congruent, that's considered scalene. So for these last examples then, you might have to be doing some figuring out of sides based upon what triangle they have here. This one here, it says if M, or if the point M is a midpoint, so if this is the midpoint of this side, even though it doesn't directly say this, each of those would be 0.75 because each of those are going to be half of the 1.5. It might be helpful for you to label that first before you go through and answer any questions about this. There are also some congruency marks on here, and because those sides are congruent, that would let you know that this side here is also 0.75 because it's going to be the same as that one. So if you need to go through and maybe mark some of that stuff first, that might be helpful, so that when you're classifying the different triangles, you have a full understanding of what's going on, because otherwise it might be kind of hard to tell just by like the look of things. So this first example asks us about triangle JKM. So JKM, this triangle here, well, each of those are 0.75, so that one would be considered equilateral. And if you just looked at like the scale of that picture, you might guess isosceles. You might guess that these sides are a little longer than that one there. But with the scale and the information that's given, you have a different answer there. What if it asked us about triangle KML? So triangle KML. Well, that one there would be considered isosceles because these two sides are both 0.75. Or the third triangle that's there would be the whole thing. So triangle KLJ. So this whole thing here. Well, this is 0.75, this side's 1.3, and the whole thing here is 1.5. So that would be considered scaling. You will have some algebra examples too. Just remember that congruent sides you just set equal to each other. So if you can remember that, you should do pretty well with these. For this one here, it says find the measure of the sides. It doesn't say solve for x. Find the measure of the sides for this isosceles triangle. So when I'm looking at this, I know that these two sides are congruent. So I can set 4x plus 1 equal to 5x minus 0.5. And I'm going to go through and solve this. So let's see, this is going to be x equals 1.5. And again, the question just said find the measure of the sides. It didn't say just solve for x. So when I'm looking at this, I need to plug that back in, and I'm actually going to plug it into like each one of those to solve for x. So when I plug it in here, 4 times 1.5 is 6, and then plus 1, this side is 7. When I plug it in there, 5 times 1.5 is 7.5, and then minus 0.5 is also 7, and I would expect those to be the same. And then there's the phone. How about you guys plug it into this one? We'll see what you get. Hello? Okay. Yeah. They did in the office, Jacob. Okay, so what did you guys get for that last one? What is it? 12.5? Okay. So when you plug in 1.5 in for x here, you should get this side to be 12.5. And that would make sense because that's isosceles. Okay, so I am doing this video live for those of you that are watching it. And I have my first hour geometry class here. Give a quick shout out to them. And a quick joke, compliments of Muriel Mackey. Here, come here. Yeah, you can do it in the microphone.
Yeah, okay. Y'all get ready, because this is the only joke I know. Why do some couples not go to the gym? Why? Because some relationships don't work out.
Get out. Get out. Not my class.
Yeah, that was pretty good. It's actually the only one I know, so.
Thank you, Muriel. And then for our last example here, what we want to do is we want to find the measures of these sides for this equilateral triangle. So all of these will be the same. Sometimes students think they got to like add some up and set it equal to something else. Really, you don't need to do that. You have some choices with how you can set this up. Because all of these are the same, all of them are equal to each other. And for an equation, you just need 2 different parts. So you just pick any 2 sides that you want and set them equal to each other. It wouldn't matter which side you choose. So because it doesn't matter, I'll just say this one is congruent to that one. I could have chosen different sides. 2y plus 5 is equal to 3y minus 3. So looking at this, I'm solving for y, so I'm subtracting 2y and adding 3. So I get y to equal 8. And then what I have to do is just plug that in for each of those, and they should all work out to be the same. This is a great way to just kind of double check too what you have going on. So 2 times 8 is 16, plus 5, that side's 21. 3 times 8 is 24, minus 3 is 21. And then lastly, 5 times 8 is 40, minus 19 is also 21. So it's just kind of a good verification for that. Hope this helps, and have an awesome day.